Alright, so this lesson I'm just going to do a review of rate of change or relative rate. We have covered this one in year 11, but I'm just going to show you another 3 more questions to help you to understand a bit more about rate of change. For the rate of change question, basically we've got only 2 steps. The first step is to express one quantity as a function of the other quantity. Alright, so like it can be y in terms of x, v in terms of the radius, or area in terms of the r. Okay, doesn't matter, but depends on the question. Once we have a function, then we can differentiate the function with respect to the time, because when we're talking about related rate and all the relative rate of change, it's always in terms of time. So we're going to differentiate with respect to the time using the chain rule, and then we're going to do some substitution with information that we obtain from the question to solve questions. All right, so let's have a look at the first question here. Right, so this question says about, Julie is blowing up a spherical balloon at a constant rate of 200 cubic centimeter per second. All right, now the most important thing here is that number. This number here has a rate unit, cube centimeter per second. That's a rate unit. So that tells you the volume or the change in volume with respect to change time is equal to 200 cube centimeters per second. So that's dV over dt. Change volume over changing time is equal to 200 cube centimeters per second. All right, so that's very important information. Now we can start with the first question. First question asks us to show that dV over dt is equal to 4 pi r squared times by dr over dt. So how would you do this one? Well, the first step you do is write down the formula to find the volume of a sphere. So the volume of a sphere is equal to 4 over 3 pi r cube. Okay, 4 over 3 pi r cube, which we can prove it using integration. All right, so that's the volume of a sphere. Now we're going to differentiate that. We're using the chain rule. So I'm just going to show you the chain rule steps. Right, dV over dt, when we differentiate with respect to the time, is equal to dr over dt. So dV over dr, and then times by dr over dt. That is the chain rule. So once you finish that, then we can start to do the calculation. What is dV over dr? So we're going to differentiate that expression here, or that differentiate that function with respect to the r. Okay, so r is the per-numeral in this case. So dV over dr is 4 over 3 multiplied by 3 pi r squared. What we're doing here is we're moving the power of 3 to the front and minus the power by 1. Alright, so after we simplify it, that becomes 4 pi r squared. Alright, so now we can do a substitution. So dV over dt is equal to 4 pi r squared times by dr over dt. And that's exactly what the question asks us to prove. Alright, so that's the first question finished. Alright, question B. For question B, it says, hence find the rate at which the radius is growing when the radius is 15 centimeters. Alright, so the question asks us to find the rate of the radius. Okay, so this is what I'm going to write, dr over dt, and then question mark. So we have the previous formula here, and we're going to use that previous formula and do some substitution to work out the answer. Alright, so how do we do it? Let's just write down this formula one more time. dV over dt is equal to 4 pi r squared times by dr over dt. Now the question asks to find out what is dr over dt. So this part is a no. Alright, something that we don't know about, we want to work out. Alright, do we know what's the value of r? From the question it says the radius is equal to 15 centimeters. So r is equal to 15 centimeters. So that tells you r is equal to 15. That's easy. R is equal to 15. Alright, then what about dV over dt? Well, from the question previously, dV over dt is actually equal to 200, right? That's how it says, blowing up a spherical balloon at a constant rate, which means the volume change with respect to the time is equal to 200, alright? So that number is actually equal to 200. Okay, so that becomes a really easy question because it's all about substitution now. So now we'll just substitute everything we need. 200 is equal to 4 pi times by 15. that's just r, okay, but we have r squared, so 15 squared, times by dr over dt. Now remember, we're finding dr over dt, so all we have to do now is solve the equation. All right, and this is really easy and straightforward to do. I'm just checking if the units are consistent. Okay, yep, the units are consistent to each other. All right, so that becomes 200 divided by 4 pi multiplied by 15 squared. Okay, now you can leave the pi there, all right, and then we'll use a calculator to work out what is 200 over 4 times by 15 squared. And the answer is 2 over 9, and we'll have the pi there. So the rate of change in radius is equal to 2 over 9 pi. All right, and then that's centimeters per second. That will be the units. Okay, so that's question B. Now, question C. Find the radius and the volume. So we're going to find the radius and the volume when the radius is growing at this rate. So now the question tells us what is dr over dt. All right, so dr over dt is 0.5. And the question asks us to work out what is the radius and what is the volume at that time when the radius is growing at that rate. Okay, so what do we do? Now, we still need that formula there. Okay, so we still need dv over dt is equal to 4 pi r squared times by dr over dt. Now this time, we still know what's dv over dt. dv over dt is 200. We still know that. 4 times by pi, we have no idea about r. Please do not get confused. Previous question from question B, r is equal to 15. But question C, it's irrelevant to question B. All right, so we don't know what r equals to. All right, so I is unknown, and then we know what's dr over dt. dr over dt, it's given, 0.5. All right, so it's again, it's solving equation. So that becomes 200 equals to 4 times by 0.5 is 2. 2 pi r squared. Okay, all right, and then r squared is equal to 200 over 2 pi. That r is equal to the square root of 100 over pi. All right, so that's what r is. All right, next, the question asks us to find the volume. All right, once we know the r, finding the volume is not a really hard question to do. We're just using the formula. Volume is 4 over 3 pi times by r cubed. So 4 over 3 pi times by square root of 100 over pi, and you cube it. Now you can use a calculator to work out all the answers, even including the previous one. All right, so that's roughly approximately equals to 5.61. Okay, sorry, 5.64, and that's to 2 decimal places. And then for that one here, 4 over 3 times by pi times by square root of 100 over pi, and the entire thing we need to go increase the power to the power 3. Okay, so that becomes 752.25, and this is cube centimeters, and the previous unit is centimeters. Okay, so that's how we do it. All right, so it's pretty easy and a straightforward question. All right, the most important thing that you need to remember here is do not mix question B and C together. In question B, the given condition is r equals to 15, but however in question C, that's what you need to find. All right, please do not assume that r is equal to 15. But we do use dv over dt equals to 200 throughout the question, because that's just the beginning of the question. All right, that applies to all three of them. All right, let's move on to the next one. Okay, next question. Let's just read the question first. A boat is observed from the top of a 100-meter high cliff. The boat is traveling towards the cliff at the speed of 50 meters per minute. Okay, so I hope you understand what does that mean. It's a speed, it's a rate. Okay, so these are the important information here. How fast, okay, how fast is kind of speed again, is the angle of depression changing when the angle is 15. All right, so angle of depression is 15 degrees. Convert your answer from radians per minute to degrees per minute. Okay, correct to nearest degree. All right. So what do we do with this? We need to draw a diagram. Without a diagram, without a proper diagram, I don't think we can do the question, right? So let's just draw a cliff. And that's the ocean here. All right, so the cliff is 100 meters. All right, 100 meter tall. So that's 100 meter. So we have a boat. Here's the boat. That's the boat. It's not a very nice boat. Okay. This boat here. This boat is traveling towards the cliff. All right, so the boat is going this way at a speed. Okay, now, very important. When we're talking about a speed, it's changing distance, all right? So if we just let the distance to be x, imagine if that distance is just x, then the changing distance over changing time, which is the speed, is 50 meter per minute. That's really important. All right, and then this is the angle of depression. That angle here is angle theta. All right, so now if we use the property of angles on parallel lines, then we'll see the alternate angles must be equal to each other. So therefore, that is also angle theta here. So here we go. All right, the question asks us d theta over dt. All right, the question asks us how fast the angle is changing. So this is what we need to find. D theta over dt. So how do we do it? What I normally do is once we have finished drawing this diagram, I want to create a mathematical diagram so we don't have those cliffs, we don't have the water, just like straight lines. It's just much easier for us to understand the question. So I'm just going to redraw the diagram one more time. That's 100. Here's the boat, but it's just going to be a point. All right, here's theta here. That's x, and we do know what's dx over dt, and that's 50. Yeah, that's 90 degrees. All right, so this is the diagram, and the question asks us to find out what is d theta over dt. So from this diagram, now we need to create, we need to express one quantity as a function of the other quantity. We need to create a function to combine that 100 and x and theta all together, all right, in one function. So how do we do it? Well, it's a right angle triangle, so why not we're just using SOHCAHTOA to do it? So how do we solve it? We write on tangent theta is equal to 100 over x. Right? Tangent theta is equal to 100 over x. That's really easy. Tangent theta equal to 100 over x. Once we finish that, we need to differentiate. Now, there are a couple of ways you can do that. All right? You need to differentiate both equations on the left and the right with respect to time. Okay? That's the most important part, with respect to time. The way I would do it, there's a couple of ways you can do it. The way I would do it, I would just differentiate both sides. All right, sorry about that. Let's continue with this question here. I just have to go ahead and deal with my with the kids. Okay, so tangent theta is equal to 100 over x. So once we get to this point, the next step is I just need to differentiate, right? Differentiate with respect to the time. So but before we do that, we just change that into x equals to 100 over tangent theta. Which is equal to 100 cotangent theta for easy differentiation. Now I can differentiate both sides with respect to the time. Right, so I'm just going to differentiate this one here. Differentiate cotangent theta is negative cosec square theta, and it times by d theta over dt. That's what we need to get. All right, now dx over dt is equal to negative 100 over, let's change that cosec square theta back into back to sine square theta, and we're times by d theta over dt. All right, so let's see what information we have and what do we need to find. The question asks us to find how fast, or what is the how fast the angle of depression changing when the angle of depression is 15 degrees. So this angle here is 15 degrees at that instant. We need to work out how fast the angle of depression is changing. Excuse me. All right, so how do we do it? Do we know dx of dt? Well, yes, we do. That's equal to 50. So here is 50 is equal to negative 100 over sine 15 degrees square times by d theta over dt. Then the rest of the step, it will be just using calculator, work out what is d theta over dt. Right, so the d theta over dt, after using a calculator, the answer is equal to negative 0.033496, and it goes on. That negative rate just means it is changing. So it's like becoming smaller. All right, so the angle is getting smaller and smaller, and that's why the rate is the angle is decreasing. All right, now so the next one is we need to change that. That is radian per minute, and according to the question asks us to change that number or change that rate to degrees. All right, so how do we change it? D theta over dt is equal to negative 0.033496, and we multiply this number by 180 over pi. All right, because we want to convert the rate to degrees, 180 over pi. So let's try to do that. Okay, so the answer here is minus 1.91904. Okay, all right, so that's not that's roughly equals to negative 2 degrees. So therefore, the angle of depression is changing 2 degrees per minute. Okay, so that's how we do this question here. All right, now this question, not an easy question. All right, the reason for that is because you do need to read the question very carefully, draw a nice diagram, and be able to, get an equation, all right, get your function, and once you get a function, you need to be able to differentiate the function and be able to substitute the numbers inside the function to work out the answer here. So it's not a really easy question to do, but this is how you do it, okay? All right, so let's have a look at the next question. Question 9. The question says, the volume of a sphere is increasing at a rate numerically equal to its surface area at that instant. Show that di over dt is equal to 1. Now, how do we do this one? If we look at this question, it says the volume of a sphere is increasing at a rate. So the volume of a sphere is V equals to 4 over 3 pi r cubed. And the volume of a sphere is increasing, so dV over dt is equal to 4 pi r square dr over dt. Right, that's just the differentiation using the chain rule. All right, and then it says the volume of a sphere is increasing at a rate numerically equal to its surface area at that instant. So that rate is equal to the surface area of the sphere at that instant. So what is the surface area of a sphere? Well, the surface area of a sphere is 4 pi r squared. So that means these two are equal to each other at that instant. And then the question asks to show that dr over dt is equal to 1. That's a pretty easy one now, because once we get that equation going, okay, we can solve this equation by finding out what is dr over dt. And that becomes 4 pi r squared divided by 4 pi r squared, and we get 1. And that's how we prove the question here. That's a really easy question. Okay, that's all I want to teach you for this this exercise. Pretty easy. It's just a revision from year 11. Make sure you try the questions here and let me know if you have any questions. Okay, thank you.